In this math lesson, we're going to be working on solving two-step equations that involve all sorts of negative numbers, negative whole numbers, fractions, you name it, it'll be in this. And two-step equations they work the same way as a one-step equation would. If you have more than one step, you're still going to be using inverse operations. And the goal is you still need to find out what x equals, but because there is more than one step involved, you need to figure out which operation should you inverse first, because you can't just pick and choose and do it however you want. There's a way in which it should be done. And so we go back to our analogy of a scale, and whatever you do to one side, you have to do to the other. But what do I do first to the one side? And then what do I do second? And what do I do third, etc., etc.? Well, if we were going to solve any old normal math problem, we would need to follow an order of operations. We would need to follow PEMDAS, or whatever version of PEMDAS you go by. I say PEMDAS. We do things in parentheses first, then we do any exponents, then we multiply or divide, whatever comes first, left to right, and then we add or subtract. But since we are going to be doing inverse operations, we are going to work backwards through PEMDAS. So if you have more than one step and you're like, what do I do first? Well, think about what you would typically do, PEMDAS, and then just work backwards through it. Some people will call this, to help them remember, SADMEP. I don't really say that because it just becomes another confusing thing to remember. I just know that normally I follow this order of operations, and if I'm going to undo or inverse a problem, I am going to go backwards through that order of operations. So first, I'll look for any addition or subtraction to undo. Once I've taken care of that, I'll look for multiply or divide to undo, and then I'll just keep on going. So the best way to do this is to do some examples, so let's do some. In this problem, there are two operations. 3x plus 5 equals 2. There's multiplication right here, 3 times x, and clearly there's addition right here. So I have two operations. Which should I inverse first to solve this problem? Well, typically I'd be following PEMDAS, and I'm going to go backwards through that order. So the first thing I'm going to look for is there any addition or subtraction to take care of? And there is, so I'm going to do that first. The first thing I'm going to do is inverse the addition by subtracting 5. And inverse operations cancel out. Whatever you do to one side, you do to the other side. So 2 minus 5. All right, let's rewrite our equation with what's left over. On the left-hand side of the equation, the 5's canceled out, and so we're left with negative 3 times x. And on the right side of the equation, 2 minus 5 is negative 3. So it's almost as if I have a brand new equation. Negative 3 times x is equal to negative 3. Well, since it's multiply, my inverse is to divide by negative 3. Inverses cancel out. Whatever I do to one side, I do to the other side. And I am left with now x is equal to, and negative 3 divided by negative 3 is positive 1. And so the answer, the solution to this equation is x is equal to 1. And we can test that out. Negative 3 times 1 is negative 3, plus 5 is positive 2. That is my solution. And we did this problem by working backwards through our typical order of operations to inverse this problem. Let's look at one with fractions. It's no different than the one we just did, other than the fact that I have fractions. I have x divided by 8, so there's one operation. I'll make a little mark here, or I'll put a 1. There's one operation. And then minus, there's our second operation. So I've got two operations to undo. And typically, I'd be following PEMDAS. I'm going to go backwards through that. And so I'm going to look to undo my addition or subtraction first. There is subtraction. I'm going to do this first. I'm going to add because inverse operations undo one another. And so I'm going to add on this side as well. So on the left-hand side of my equation, I'm left with x divided by 8. And on the right-hand side of the equation, negative 7 plus 1 is negative 6 over 2. All right. Also, negative 6 over 2. 6 over 2 is the same thing as 3 if you were to just simplify that. So maybe I'll actually just rewrite this. X over 8 is equal to negative 3. All right. Last step here. How do you undo division? You multiply. So I'm going to multiply by 8, cancel out, multiply by 8. And my final answer here is x is equal to negative 24. Boom, done. That is my final answer. You could check it if you wanted to. 24 divided by 8 is 3. Negative 3 minus a half is negative 3.5, which is the same thing as negative 7 over 2. So that checks out. Cool. Another example. More. Now, in this problem, it looks like there's multiple operations, but I'm going to show you a little trick here. We have 3 times y minus 8 times y is equal to 25. This and this, the things I underlined, these parts of the equation, these are like terms. They are parts of an equation that have the same exact variable raised to the same exact exponent. They both have a y. I like to think of it as they have the same last name. They're both y's. They're in the y family. And that's important because if you have like terms, you can combine them. You can put them together. So if I have 3 y's and I subtract 8 y's, I'm down to what? Negative 5y. So combining like terms, you take that first number in front of the last name, it's called a coefficient, and you just add or subtract them depending on what operation is there. There's a subtraction sign, so it's saying 3y minus 8y. Well, 3 minus 8 is negative 5, and it keeps the last name of y. So now I have a shorter expression. Now it's just like a nice easy one-stepper. 5 times y, I'm going to divide by negative 5. That's the inverse. So divide by negative 5 on this side, and I'm left with y is equal to negative 5. Positive divided by a negative is a negative. 25 divided by 5 is 5. So when possible, if you have like terms on either side of the expression, it's a good idea to, before you do anything else, combine them, put them together, and then solve your problem. Let's look at one more example, and it's going to be similar to this one. I've got negative 6 is equal to 1/4 w minus 1/2 w. Ooh, I've got 2 terms that are both on the same side of the expression. They're both on the right side, and they both have the same last name, so to speak. They're like terms. So that means I can combine 1/4 minus 1/2. So 1/4 minus 1/2. To do that, I need to have common denominators. So I'm going to keep 1/4 the same, but I'm going to make the second fraction 2/4 by multiplying this whole thing times 2. Anyways, now the denominator stays the same, and on top, the numerator, 1 minus 2 is negative 1. So if I combine these two like terms, my equation can be rewritten as negative 6 is equal to negative 1/4 w. So you see what we did there, we shortened the equation, we made it a little bit easier to work with. There's less steps involved now, and now it's a nice one-step equation. I got negative 1/4 times w, which means I'm going to inverse operation, divide by 1/4. When you divide by a fraction, it's the same thing as multiplying by the reciprocal. So this cancels out, and I'm going to do the same thing over here. And so I've got a negative times a negative. So I know my final answer is going to be positive. And 4 times 6 is 24 over 1, which is just 24. So the solution to this equation is W is equal to 24. And that's today's lesson on multi-step equations. With these, obviously take your time and reach out with questions if you have them, as always. But look to go backwards through your typical order of operations instead of following PEMDAS. The way that you undo these is look for addition, subtraction, multiplication, and division, and then so on and so forth. Otherwise, good luck. Happy practicing. Bye-bye.